Hello everyone, this is a worksheet on standard scores or z-scores. Now this is a very important topic, the z-scores, because we will be using it frequently in the future chapters. So let's try to solve a few problems and that will give us an understanding of how z-scores work. All right. Now the first question says the data set given below has mean 25 and a standard deviation 5. Fill in the blanks below. But let me try to chart what has been given here. Let me pull out my pen here. So what this means is I'm going to draw our number line, our horizontal line, and show the mean at the center of the line. So mu equals 25. The mean is located at the center. Remember, the mean is a measure of the central tendency, so it should be located at the center. So mu equals 25 and the standard deviation is equal to 5. Now the questions they're asking is approximately 68% of the observations lie between blank and blank. So again, you have to recall the empirical rule that we learned, empirical or the 3 standard deviation rule. Approximately 68% of the observations lie between -1 and +1. All right. Now I'm also going to find, so -1 and +1 are z-score values. These are the z-score values. But let's say we want to also know what the values are at this point. So if 25 is at the center, that means that 25 has a z-score of 0, correct? It has a z-score of 0. So let's scale this horizontal line based on z-scores. If 0 is at the center, on the right hand side, we'll have a +1, +2, and +3. On the left hand side, we'll have -1, -2, and -3. Sorry, -2 and -3. So, and we say that 68% of the observations lie between -1 and +1 according to the empirical rule, 68%. Okay. So if mu equals 25 and the standard deviation equals 5, what would be the values at z equals -1 and z equals +1? In order to find that answer, we have to go back to the formula for the z-score. All right, so I'm going to write here, all right, z equals, remember the formula for z-score, it's x minus mu over sigma, right? So what we are trying to find is the x value corresponding to a z value of -1 and a z value of a +1. All right, and let me correct this. This is not like an exponent. It is a z value, all right? So let's say this is a z value. All right, so we know the value of z that we are looking for, whose x value we are looking for. We know the mu is given to us, and we know sigma, which is also given to us. So let's try to solve this. So -1 equals x minus 25. Remember, mu is 25. So x minus 25 over 5. All right, so now you have to solve for x. This is algebra at this point. So how would we do that? X, all right, x can be solved using this formula. Mu plus z times sigma. All right, so mu plus z times sigma is, you just have to multiply. You can just solve for x from this equation as well. You don't need a formula really. So if you want to solve from this equation, what do we do first to get rid of that 5? Remember, in solving an equation, we have to isolate the variable on one side, get everything over to the other side. So first we start with the 5. So to move the 5, we have to multiply both sides by 5, isn't it? 5. So 5 divided by 5, and what are we left with? Negative 5 equals x minus 25. X minus 25. What did I do here? Minus 25. All right, let me do it separately here. Bear with me, please. Minus 5 equals x minus 25. So x will be negative 5. All right, negative 5 plus 25 plus 25 so x will be 20, correct? So if you want to use the formula, you should get the same answer. Mu is 25, mu is 25 plus z is negative 1 times 5 should give you 25 minus 5 is a 20. So this would have a value of 20. All right, so we can say x within brackets, x equals 20. On the other side, when x is positive 1, you can do the same. All right, x equals mu plus z times sigma. So let's just substitute. X is 25, mu is 25 plus z is 1 times 5. So it's going to be 30, right? So it's going to be x equals 30. This way we can answer the rest of the questions or rest of the parts of this question. It says approximately 95% of the observations lie between blank and blank. We know it's minus 2 and positive 2 for z values. Let me just write it. All right, so z equals negative 2 and z equals positive 2. But we also want to know the x values. So just use this formula here. X equals mu plus z times sigma. So x equals 25 plus minus 2 times 5, which will be x equals 25 minus 10, and that's going to be 15, right? This value here is going to be 15. Positive 15 on the left-hand side, and it should be 35 on the right-hand side. All right, so this would be 15, so x equals 15. And on this side, it would be 25 plus 2 times 5, 10. So 25 plus 10 would be 35, right? And then approximately 99.7% of the observations lie between a z value of negative 3 and z equals positive 3. So to find the corresponding x value, again, use this formula, x equals mu plus z times theta, z times sigma. So it's going to be x equals 25 plus minus 3 times 5, which is 25 minus 15 will be 10, right? So x equals 10. And on the right hand side, at z equals 3, our x value will be 25 plus 15, so it'll be 40, right? So that means this value here is 10, and on the other side this value here is 40. All right. So that is how you answer the question number 1. Now the second problem on z-scores is slightly different from what we just worked. It says here the data set has mean 15 and standard deviation 2. Approximately what percentage of the values lie between 13 and 17? So this time they want to know what percentage. Earlier they were asking what were the z-scores and the x values for the different percentages. They had given us the percentages and they were asking us to answer with the z value and the x values. This time they have given us the mean and standard deviation, but they've given us the x values and they are asking us what percentage of observations will lie between this set. So I'm going to start by drawing the horizontal line. Having a figure always helps, all right, to kind of visualize the problem. So this is our standard normal curve, all right, and z-score of 0 will always be located at the center of the curve. And then on its right side, we'll have a z value. These are all z values, all right? So on the right of 0, the first cut will be a 1, then a 2, and then a 3. And on the left-hand side, it'll be -1, -2, and -3. -3, all right? So they've told us that mu equals 15. The standard deviation is 2, and they are asking what percentage of observations lie between 13 and 17. So 13 is going to be to the left of wherever mu is, which is the center point, and 17 is going to be to the right. So the lower value is going to be to the left, and the higher value is going to be to the right of the center point where the mean is located. So if we can find the corresponding z values of 13 and 17, then we can tell what percentage of values will lie between that interval, okay, between those two observations, in other words. So in this case, we have to find the z values, all right? So 13 is one of the x values given to us, so I'm going to call that x sub 1, and 17 is going to be is the other x value, which is x sub 2. So we have to find the corresponding z sub 1 and z sub 2 values. Again, the formula for z value for individual observations, when we are given individual observation values, then the formula for the z-score is x minus mu over sigma, correct? So to find z sub 1, you have to substitute x sub 1 value, which is 13, minus 15, that's the value of mean. Let's write the values here. Mu equals 15, sigma equals 2, x sub 1 is 13, and x sub 2 is 17. X sub 2 equals 17. So we are first trying to find z sub 1. So 13 minus 15 divided by positive 2, that would be negative 2 divided by 2, which gives us a z sub 1 value of negative 1. All right, so that means 13 is located on our figure on the graph. 13 is located where negative 1 is, right? That's 13. This was 15, that's 13. Let's find the z sub 2 value now, the z value corresponding to 17. All right, so that'll be 17 x minus mu, so that's 15 divided by, let me not overwrite, 15 divided by 2. So 17 minus 15 is a positive 2, divided by 2 is a positive 1. So that means 17 is located where at a z value equals 1. It's 1 standard deviation away from the center point. So that's where 17 is located. And recall the empirical rule. What percentage of values or observations are found between -1 and +1? 68%, correct? We just have to remember these percentages. So the answer is going to be 68% of observations. 68, let's say here, answer is 68% of observations lie between 13 and 17, which corresponds to z values of -1 and +1, right? Now the third problem is similar to the one we worked before, except that they've given us different values for the mean standard deviation and the x values, right? So let's start working on it. It says the data set has mean 30, so they've given us a mu of 30 and a standard deviation equals 4. Approximately what percentage of the observations lie between 22 and 38, all right? So these are the individual observation values, x sub 1 and x sub 2. So we have to find the corresponding z sub 1 and z sub 2 values given the mu, sigma, and x values. So I always like to have a diagram before me. I always like to support my answers with a diagram. That way it helps me to stay on the right track. All right, so let's say this is our normal curve, and mu will always be located at the center point. So that's where the 30 will be. And 22 is less than 30, so it will be located somewhere to the left of 30. So let's mark that x sub 1 value as 22, and somewhere on the right hand side will be our 38, right? So x sub 2 value equals 38, and the standard deviation is 4, correct? So we have to find the corresponding z values for x sub 1 and x sub 2. The center point where mu is located is always going to have a z value of 0. That's a no-brainer. It does not need any calculations. So let's use the z value formula that we learned for individual observations and come up with the z values. So z has the formula x minus mu over sigma, correct? So z sub 1 will be x sub 1 is 22 minus 38, which is mu, divided by sigma is 4. So, all right. Sorry, it's 30. I don't know why I wrote 38. Let me erase this. This should be a 30. 22 minus 30 divided by 4. All right, by mistake, I wrote this 38, which is the x sub 2 value for mu, but that was wrong. Mu equals 30. It's x minus mu. I just want to correct myself and also point out what I said before was incorrect. So 22 minus 30 divided by 4 is -8 over 4, which is a z value of -2. So that means this z value is -2, corresponding to 22 is -2. So for 38, which is going to be our next z value, z sub 2, it's going to be 38 minus 30 divided by 4, which is +8 over 4 equals 2. So if we extend the vertical lines here, all right, this interval between -2 and +2, +2 covers 95% of the observations, 95% of the observations, right? So we are going to write for our answer as 95%, and that we know using the empirical rule that was given to us. And so 95% of observations lie between x equals 22 and x equals 38, right? Between this interval. Okay? Question number 4 is slightly different. It says here the data set has size 60. So there are 60 values in the data set. Approximately how many observations lie within 3 standard deviations to either side of the mean? All right. So here they are not asking what percentage. It says how many observations. You have to give them a number as an answer and not a percentage value, 68% or 95% or 99.7% and so on. All right. So n data set, that means our sample size, our the size of the data is n equals 60. All right. Now the standard deviations that are within 3, right? Within 3 standard deviations. Again, let me draw a figure here. They haven't given us the mean, but we know that mean will always be situated at the center of the curve. So whatever the mean may be, it'll be located here, and its distance from the center point is 0. If mean is located at the center point, then its distance from the center point is 0, right? So that's why it has a z value of 0 at the center. And then they've given us the z values, which are within 3 means plus minus 3, correct? So negative 3 z value and a positive 3 z value. And they are asking how many of observations of these 60, how many of these 60 observations would be within this interval, negative 3 and positive 3, within this interval. All right. So again, using the empirical rule, we know that 99 point by the empirical rule, 99.7% of observations lie between. All right, try to be as thorough and precise as possible in your answers. All right, observations lie between negative 3 and positive 3 standard deviations. Okay, so out of 60, the number of observations that would lie between this interval would be 99.7%. So what you have to do is you have to find 99.7% of 60. That's the calculation we have to do. How do we do that? 99.7% of 60 is 60 multiplied by, you have to divide 99.7 by 100 and write it as 0.997, which will give us a value of 59.82. 59.82. Of course, number of observations have to be an integer value. It has to be an integer value. So 59.82 has to be rounded up to 60. All right. So that means almost 100% of the observations will lie. 60 observations will lie in the interval -3 and +3, right? Here's another problem similar to the one we just worked out, except this time with a different sample size, different data volume, and different standard deviation. So it says the data set has size 50. So n equals 50. Approximately how many observations lie within one standard deviation to either side of the mean? So one standard deviation, within one standard deviation would be plus minus 1. Again, I'm going to draw my diagram here and have a picture so I know what I'm looking for. So again, mu is going to be at the center point, and we don't need the mean, the value of the mean or the standard deviation, right? But we know that the mean will be located at a z value of 0. That's where the mean will be located. And then plus minus 1 standard deviation. So that means our horizontal axis will be scaled by z values, all right? So -3 would be here, let's say, then -2 and -1 here, and +1, +2, and +3 perhaps here. So -1 and 1, right? We know 68% of observations will be contained between -1 and +1. So all we have to do is we have to find 68% of 50. Again, they haven't asked for the percentage. They have asked us for the number of observations that will lie out of 50. All right. So 68% of 50, again, the way you will calculate it is 50 multiplied by 0.68, right? 68 divided by 100 times 50. And that should give us a value of 34 observations. So answer is 34 observations out of 50 out of a size of 50 will lie within one standard deviation. Let's just try to answer the question the way they have asked, within one standard deviation to either side of the mean. To either side of the mean, okay? The mean. Perfect. Now the final question in this worksheet is similar but a slight extension of the questions that we worked immediately before this, all right? It says here the data set has 150 observations and has a mean of 35 and a standard deviation of 4. Approximately how many observations lie between 31 and 39? All right, now in the previous questions here, up here, we were just told the unit standard deviations, right? How many observations lie within 1 or 2 standard deviations to either side of the mean. Here, they haven't given us the z values. They've given us a value of the mean, they've given us a value of the standard deviation, and they have given us 2 x values, all right, and n. So I'm going to list the data. They have given us n equals 150, and then mu equals 35, sigma equals 4, right? This sigma, standard deviation. X sub 1 equals 31, and x sub 2 equals 39. So they've given this data to us, and they are asking how many observations lie between 31 and 39. They haven't asked us what percentage. They've asked us how many of the 150 observations lie within this range of x values. So you have already worked problems in parts of this problem previously. So what we need to do is we need to find the z values first, and then from the z values we will see if we can determine the percentage of observations, and from the percentage we can find the number of observations out of 150. All right, again I'm going to start with my diagram here. Here's my diagram with the mean at the center. So how much is the mean? Mu equals 35, correct? And standard deviation equals 4. And x sub 1, which is 31, will be located to the left of the mean. So let's mark it somewhere here. All right, let's mark 31 here. So that's x sub 1 value. All right, that's x sub 1 equals 31, and x sub, all right, this is x sub 2 equals 39. So we have to find the corresponding z values. Now at the center point where mean is, the z value is always a 0, but we have to find the z values at x equals 31 and x equals 39. So we'll first find z sub 1. Keep the formula before you so you can apply the values correctly. It's x minus mu over sigma. So for z sub 1, it's going to be 31 minus, what's the mean? 35 divided by 4, which will be negative 4 over 4, which is negative 1. For z sub 2, it's going to be 39 minus 35 divided by 4 is positive 4 over 4, which is positive 1. Right? So now we have our z sub 1 and z sub 2 values, which are negative 1 and positive 1. And if I extend a vertical line through those values up to the curve, then it says by the empirical rule that 68% of the observations will lie between negative 1 and positive 1. Right, between negative 1 and positive 1. So they haven't just asked us for 68%, the percentage value. They want to know what number of observations, right? How many observations? So we have to find 68%, and I'll try to be thorough and answer the question as completely as possible. So 68% of observations lie between z equals negative 1 and positive 1. Therefore, 68% of 150 equals 150 times 0.68, which is a value of approximately 102 observations. So 102 observations lie between 31 and 39.